Hello, my name's Dean and welcome to the Obsolescence Management podcast from Alan Webb. And with me today, I've got David Williams. Hi, David. How are you?
Good morning. I'm fine. Thank you, Dean.
Good. And Tim Elliott, how are you today?
I'm fine. Thank you, Dean.
Good. So you both are kind of experts in obsolescence management. David, would you like to give me a short introduction to what you do at Alan Webb and where your obsolescence management projects happen and where they start and where they finish?
Yeah, absolutely, sure. I support Alan Webb in a number of programs and capabilities for obsolescence management, based on my history, which goes back to the 1990s when I had PLC responsibility for these type of programs in terms of providing capability with Marconi Electronic Systems, and then subsequently with BAE Systems PLC. And again, in that time, we introduced obsolescence management across a number of companies within the BAE Systems framework. Since then, in 2010-11, I formed with Stuart Kelly of the MOD a company called Through Life Support, focusing on obsolescence management. And from Stuart and I's partnership, we actually started what was now known as the International Institute of Obsolescence Management, of which both Stuart was president and I was technical director until 2019.
And Tim, yourself, what's your experience with Alan Webb and beyond that, before that?
So my role in Alan Webb is head of obsolescence management capability. So I'm responsible for keeping up to date with current practice, policies and procedures, and ensuring that the training material that we have and the scrapness of the people who work in the capability can support projects and programs for the clients that we have. So I'm currently providing consultancy on the Dreadnought program for BAE, as is David. And we're there trying to set up a capability and service to support the Dreadnought and in fleet submarines there. My previous background has been about 30 years in defence and non-defence work, where I've had looking at obsolescence from an asset management, availability and sustainment perspective, and understanding how obsolescence impacts businesses and different functions and what it means to them, which is why we're doing this podcast, to allow people to affiliate themselves with what obsolescence means and what the triggers to look for.
So Alan Webb are heavily involved with the defence industry and obsolescence, which obviously can be mission or safety critical, can't it? But the obsolescence is all across industries all over the world, isn't it? What do we mean when we say obsolescence management?
Obsolescence management is a capability to minimize the risk to a business of any issue that is going to become in the future an obsolescence risk to that company. We split it into two basic areas. One is issues. That means something is already obsolete that we've got to react to. And the other one is risk. And this is looking at a future going forward as many years as what the customer would like, to define the risk of obsolescence to their contracts, to their programs, to their equipment. Predominantly, obsolescence occurs because the items that go into a piece of equipment or a product actually have less life than the actual life of the equipment they enter into, and that's what causes obsolescence.
I was going to say, for obsolescence, for me, obsolescence management is asset performance and sustainment. It's the knowledge, the processes, the people, the organisation that you need to set up to enable the longevity of an asset and understand what the availability of that asset means across various functions, from designing the asset, making sure that you've got longevity in the items that go into it, through to the support solution arrangements, and right through to disposal, so the whole product life cycle.
So it's not about the whole unit. Let's take a car, for example. It's not about a car. The most likely things to become obsolete within a car are the elements within it. Can you give me an example there, Tim, of one of those elements within a car?
Right. So we've seen obsolescence in the car industry impacting the availability of car models and the costs going up due to silicon not being available, and the shortage of silicon. Therefore, the production lines have been impacted, which means that on some models you haven't had the various capabilities or options that you might want, such as sat nav and others. So, not saying obsolescence could have solved that problem if you'd been aware of it, but certainly you could have looked at what other alternatives or what strategies you could have put in place if this particular occurrence was to happen again, to sort of maintain the production lines that you need. And we're seeing more and more companies now having obsolescence managers or resilience managers in place to ensure continuity of production.
We'll come on to that role later on in the podcast. But David, what drives obsolescence management? Is it technological changes? Is it legislation, or is it anything else, or is it a mix of all? What drives it really? What's the main factor, I suppose?
It's a mix of all of those issues that you come across there. In the world of technology, you've only got to look at, for example, in 1969 when the moon landing first occurred. That if you look at the spacecraft, it's basically toggle switches and red lights, not a lot more, with probably a few megabytes of memory. You look at your iPhone that you now have; it's got significantly greater power than what the capsule we sent to the moon is, and that's all within 20 or 30 years. You look at submarines, for example, in 1879, the first submarines were steam powered. By the 1950s, in the 50s, 60s, they were nuclear powered. So there's a significant technological changes that happen in those period of times. And of course, what you then tend to see is that the consumer products are actually driving a huge amount of technology change and availability of the items to the aerospace and defense industry as well.
That sounds like it's a really difficult job to manage obsolescence. How on earth, Tim, do we find what's going obsolete? How do we manage the whole thing? Because there are in any element, in any like the rovers on Mars at the minute, in David's space example, and just generally back to maybe in defence, like a battleship, for example, which has literally millions and millions of parts. How on earth do we define an item going obsolete? How does that process? How is that managed internally?
Well, we have a number of tools available to help us manage these sort of programs. Now, technically, the biggest risk of obsolescence sits around the electronics world. And the electronics world have a number of really good support tools that allow you to do prediction and assessment of obsolescence. We're fortunate in Alan Webb, we have our Diamond OM tool that allows us to do this. So although obsolescence in electronics, electromechanical items is probably the biggest risk, it's probably the one that it is the one where we have more information to enable us to manage that sort of process. Going beyond that, we're starting to see much greater vulnerability to software obsolescence. And we've been involved in a number of software programs looking at the obsolescence, predicting the life cycles, using roadmaps, working with the developers, and also looking at third-party provision of data as well. So if you look at the actual pure items, that's where most of it sits. We shouldn't discount mechanical, but there are issues around mechanical, but they tend to be handled on a one-to-one basis. Now, if you look at the availability and discard availability, then you start to look at what happens with legislation. Then there's a whole raft of different things that come into place. We're all pretty familiar with ROSH, which with restriction of hazardous substances that came out in 2006, which listed 6 chemicals that are considered harmful to the individual. This is now somewhere up to about, I think, 13 in the latest release of ROSH. And then following on from that, we had REACH. That is basically a large impact on substances of very high concern that now affect a huge amount of programs based on the manufacturer's use of these chemicals. And that manufacturer could be yourself in a process, or it could be who make equipment items that go into your equipment. The third one that comes into this area of legislation in terms of chemicals is called POP. This is pollutants, persistent organic pollutants, and this is legislation aimed at stopping a number of, again, substances of very high concern entering into the food chain. Now, that might seem quite obscure to industry, but of course, when we use those sort of pollutants, then it actually does go, we have to dispose of them or have to be recycled in some way. So there's legislation looking at these harmful chemicals that stop it getting into the food chain. And then we can move on from that in terms of commercial legislation. And ITAR is one that is certainly outside of America, we have to be very cognizant of. If we're using items that are ITAR registration in the US, then we have to, as in organizations, we have to track where those items are used. Even if our equipment is sold from one country or one supplier to another supplier, it is still the responsibility of the manufacturer to know where that equipment, whether it's commercial, whether it's defense, is being used. So that's, and the penalties for ITAR is quite significant in terms of money.
Tim, one for you. David mentioned there Diamond OM as your software to manage obsolescence management within anywhere from defence to industry. Can you just give me a broad overview of what Diamond OM does and what benefits it has?
So we use Diamond OM with it's an obsolescence management lifecycle tool. We use it as a means to support a client, look at the client's products, bills, and materials, get the configuration of those bills and materials as accurately as we can. Then we review the bill of materials to remove the low complex technologies, nuts, bolts, washers, unless they're special to type, identify the electronics, identify the mechanicals and non-mechanicals. And then looking at inventory and stock levels, decide which items need to go forward to become the managed bill of materials. That managed BOM, we then managed item list. That item list then gets loaded into Diamond OM, and its indenture is set so it looks exactly as it would do in a configuration account. So a number of systems can be made up to equal the platform. From there, we would then use the obsolescence management team to go ahead and status and lifecycle status the managed bill of material, managed item list. From that, you would then identify what the risk would be for availability of those items and what the impacts would be. And that could be legislative or availability again. This is done through the data mining, technology roadmaps, upgrade paths, information from OEM sources. So we get a complete picture of the availability of the asset. And then we report that information in an analytical report back to the client, typically on a quarterly basis if it's electronic, or on a yearly basis if it's mechanical items. Where we do find a problem, an obsolescence arising, then we use the case resolution module within Diamond OM that allows us to go out and find a fit, form, function interface replacement, make those recommendations to the client, and the availability of that resolution. But it's up to the client, who's the design authority or product owner, to actually underwrite that resolution and then incorporate that into their product.
So does it give a visual representation within Diamond OM on things like year to end of life or year to end of supply? So you can see when your items are becoming obsolete or not available from suppliers. It might not just be an item that's going obsolete. It might be that the supply chain is reducing. Is that right?
Yes. So again, through data mining and researching the supply chain, we do get that information that gives you years to end of life, at item level. Then you can then review that at the asset level, then to decide when you might do an upgrade path for a particular asset because a number of items are going obsolete. We also look at other risk impacts such as single source suppliers. So understanding what that strategy would be if that supplier was to go under, where would you go? What would you do? So we part of the assessment we do will be to inform the client on that one. And anything else, from legislation or any other mission criticality, safety criticality, inventory, all of it is taken into consideration from a risk perspective and availability perspective to give you that overall risk impact to that asset or system.
Very clever tool. Is it being used currently? I think it's been used in defence, isn't it?
So predominantly the tool is used on a number of defence programmes and clients, but the principles by which you apply the rules to using Diamond is not just defence orientated, it's non-defence as well. So we have got a number of clients outside of defence who have similar assets to defence clients, and so the information, the way they manage their asset is exactly the same. So it's transferable skills and knowledge and principles into a non-defence marketplace.
I'm going to drop a link in the bottom of the video for the website for Diamond OM, and there are some demo videos on there. So if you are interested in that software, you can actually have a look at live demos in there to see if it fits your business. So let's move on to the obsolescence policy. David, why does a company need an obsolescence policy?
Well, firstly, an obsolescence policy is one of the requirements of the IEC 62402 2019 standard. So it is a requirement of the standard that has now been put in place for obsolescence management. What a policy does, it gives us governance over the business, and the business can be whatever size of business you like and whatever type of industry and sector you're in. But it's a fairly short, concise document that states how a company will manage obsolescence that can be used then to forward into what's called the obsolescence management plan, which is another subject for a podcast. So the policy contains how you're going to manage obsolescence, how you're going to separate obsolescence in, how you're going to put it into your business, the stakeholders and family tree of the stakeholders and how they sit in your organizational structure. It will say what type of documentation you're going to also incur, as well as 62402 2019. It will define what your obsolescence management plan will be. It defines what your obsolescence risk assessment will be. So it's basically an overall arching document that controls obsolescence in your organization. And it should be for all products that you as a manufacturer or a support agency have responsibility for.
Tim, David mentioned the IEC 62402 2019 there. Where does that govern? I mean, is it across all sectors? Is it a specific sector? Is it specific countries? I mean, what's the spread of this and how impactful it is across the globe?
So the IEC 62402 2019 is an international standard and is being adopted by many countries. The UK have adopted it for a number of years now, but we're now seeing its introduction of recently to France, Germany, India, across America, Australia, Japan. So the standard itself, as I say, is an international, and we're about to go through a refresh of the standard. And on that committee, there are numerous countries who are contributing to the content and the change of the content of that standard.
what I would see as a potential issue with this standard and people adhering to the standard is a supply chain. It's okay getting your obsolescence management structure solid within the business that you work in, but most businesses require the support of a supply chain, both upstream and downstream. So how on earth is that managed from inside your own organization? How do we ensure that people are within your supply chain are adhering to these standards? And, how does that contracting work?
The requirements that are placed on you from your client, you would roll those down to your supply chain or through your supply chain. The issue you may have will depend on how big an organization is to whether they can manage obsolescence, because you could end up with a man in a shed who, or for that person to respond to the obsolescence demands, could be quite costly, and so they probably won't adhere to them. So you need to look at ways that you can support your supply chain with information and organisation to allow item availability information or risk information to come back into you. Now that could be through various tools like Diamond OM, or even something like Project Workshare.
So the contracting obsolescence, as Tim said, is really dependent on what you're looking to put down your supply chain. IEC 62402 2019 does have an element in it that requires or provides guidance on how you can do some of the supply chain contracting. 62402 2019 actually doesn't cover contracting, but it does cover the use of the supply chain. And one of the things that we've been involved in, and I've been involved in, I think I've assessed over 180 companies now, is doing a supplier assessment to look at whether a supplier or manufacturer, or in 62402 2019 terms speak, a contractor, can comply with your requirements for obsolescence. And normally, again, dependent on the size of the piece of equipment they're producing, you would look to see an obsolescence management plan from the supplier, and with that would be the supporting obsolescence risk analysis. And again, that would form part of your OMP and how you're going to manage your supply chain in your OMP and in your certain extent policy as well. The issues that you put down to your supplier would obviously have to flow through to you so that you can then understand the risk to your projects. The supplier assessment that we use in Alan Webb is based on what was then the UK MOD's Tomcat tool question set. We've actually expanded that, and we would look to see risk analysis and evidence of risk analysis from the suppliers that we engage in that. Tim's quite right. You wouldn't expect a small supplier to produce that. You wouldn't expect a small supplier of a very small equipment to produce an OMP. But anything of significance, the supplier or the contractor or the manufacturer should provide you with an OMP and a risk assessment with updates on an agreed basis with you as the customer.
So the accreditation guidelines, whose responsibility is it? Let's say that someone within the supply chain didn't comply with this accreditation. Who's responsible? Is it you as a business, or is it them as a supplier? Does it all come back onto you?
In essence, basically, the accreditation will be dependent on the contract you have with the supplier and how you've got contracted to you from your customer. But at the end of the day, you as the owner of the product you're delivering, it's your name that delivers it. So therefore, and I hate the term brand, but the brand and any sort of criticism comes back to you, irrespective of what happens in the supply chain, irrespective of what penalty clauses you may have with a supplier. So it is basically the deliverer of the customer who actually has to face the issues about any poor supply.
I would suggest accreditation is the wrong word, because you're not accredited like you are, like ISO 9001 in the quality management system, that you reach a standard. So it's more of a contractual requirement that's placed on the prime, who then flow that down to down the supply chain. But one of the key elements that we are seeing within 2019 is the resilience of the supply chain, as David's already articulated. What is that risk and how are you managing that risk? And what we're seeing, certainly in some of the clients that we're dealing with, is the lack of experience to understand what that risk is to the supply chain and what that impact would be to the production schedule and delivery of product.
So in an ideal world, when you're contracting for your supply chain, you would look at them having this standard, wouldn't you? The IEC 62402 2019. That would be in an ideal world, wouldn't it?
That's absolutely right. You would want to put that in your contract, that they will manage to that standard.
Okay.
And as you select your suppliers to support your program, then when you're conducting your supplier audit from a finance perspective and performance perspective, you'd also look at the way that the supplier manages information and item risk and resolutions from an obsolescence perspective.
David mentioned the OMP, which is the Obsolescence Management Plan. It's kind of a massive subject, I would imagine. Can you just give me a brief overview of whoever sets it, whether it's an external company like Alan Webb that does it for a client, or whether there's an obsolescence management level within a business? So what would be in an obsolescence management plan in general?
Basically, the obsolescence management plan is the most important document in obsolescence management process, the whole process, because it defines the way you do it. What you tend to see is the general things like an introduction. You would definitely see the project details, what the project's about, the timing of it. One of the key things to have in the project obsolescence management plan is to have what's in scope and what's out of scope. So in scope could be just design and manufacture. Out of scope, for example, could be spares or something like that. But it's very important you actually define the scope of what you're trying to, what the plan's describing. You'll have in it also how you're going to manage that program, what you're going to do in terms of deliveries, the obsolescence management tools or capabilities you're going to provide, including how you're going to do the risk assessment, how you're going to do the impact assessment, how you're going to look at the reports you're going to produce. So all of that forms part of the obsolescence risk assessment and reporting activity. You have a communications element to it, to say how you're going to communicate with both internally within your organization and with your customer, and then also down the supply chain. You're going to, in the obsolescence management plan, you'll put in there also how you're going to manage your suppliers. And then finally, we're looking at the how we're going to do any cost incentivization, cost metrics. To the obsolescence management plan should define how you're going to accumulate costs, how you're going to look at metrics to show that the obsolescence management plan and your obsolescence management capability actually works. And then finally, and this is more to do with the bigger sustainment programs, is what they call transition. And transition is when a project that you've got responsibility for ends and it could go to another support organization. You should have the way how you're going to transition the data you've got into available for another organization. So in essence, it is the most important document you have to manage obsolescence. It isn't a small document. For a fairly small piece of equipment, I would expect to see something like 20 to 30 pages. If it's a major piece of equipment, certainly above 60 to 100. Now, as far as assessment's concerned, companies like Alan Webb do assess obsolescence management plans. We also write them. Normally, it will be the customer your obsolescence management plan goes to who will assess your obsolescence management plan. And it's obsessed, and I say again, it's assessed against the criteria in 62402 2019.
Right. Within the IEC 62402 standard, there is a section on obsolescence management plans and what you'd expect to see in there. And in one of the annexes, there is an example of how to lay out an obsolescence management plan with all the headings. And it's just a question of then populating those headings. But as David said, Alan Webb do work with clients to develop the OMPs, but it's one of those plans where you need to be an integral part of the business. You can't just write it in isolation. You need to understand. So we tend to, it takes us about 5 days to write an OMP, with 2 or 3 days working with the client directly. So we cover all aspects of the project delivery from an obsolescence standpoint.
So it sounds as though, if somebody's managed, say, if there's an obsolescence manager internally, it sounds a very difficult job. I know you guys help businesses to implement these plans and develop these plans, but from an internal point of view, if there's an obsolescence manager involved, they've got to have so many hats and they've got to involve so many other parts of the business. Supply chain, you've got to involve purchasing and procurement. You've obviously got to involve quality, the operations teams, and pretty much everybody's got to buy into it, haven't they? So, I mean, do Alan Webb, if there isn't an obsolescence manager within the business, let's say in industry, for example, is that something that Alan Webb support with, actually making sure that people are adhering to it throughout?
Well, we certainly have contracted obsolescence managers into business, and recently we have done to support that while they're trying to recruit obsolescence management roles within their own organisation. To quote one senior engineering manager, obsolescence managers are rarer than hen's teeth. And that was a quote one of the obsolescence engineering manager gave us. We were trying to recruit an obsolescence manager about a year ago. So they are quite rare in terms of availability on the market for employment. And it's also so important that the company supports the principle of obsolescence management and actually backs that up with supporting the obsolescence manager in his role. We've seen evidence in the past where obsolescence has been a requirement. We've seen companies that actually say they do obsolescence, but not supported the obsolescence process and the manager. So it is important that if you would take on a role of obsolescence management, you have the support of your company behind it.
And the people who are so-called obsolescence managers tend to be dual-hatted. So they could be a procurement specialist, or they could be an engineer, or which isn't that's their primary role. And obsolescence becomes a secondary role, and almost sometimes gets forgotten about. But actually, it's a full-time role that, as you say, engages across all functions, because obsolescence means different things to different functions. So from a commercial perspective, it may be you haven't placed a contract with a supplier for such a long time, and that supplier has either changed its product or gone out of business. So it's the role itself is a facilitator of information across the organisation to maintain the product availability and services availability. And many organisations actually outsource that service, and then they just have a central point back in the prime itself that we would. So Alan Webb have a number of projects. David's a project manager for 2 or 3, and he will then be client facing in terms of reporting obsolescence on the projects that he's responsible for to the client, and then the client makes those decisions on what they want to do.
So let's stay on the role of the obsolescence manager, because it is a fairly rare title, isn't it, that you see, certainly through industry. It seems like a luxury item to some, I would say. But what's the ideal candidate for somebody like that? What background would they come from if a business was to hire one?
From my perspective, I would look at some sort of technical experience, understanding engineering, maybe support, but certainly I find that, and it's not always the case, but I find that the most effective ones have an engineering type background. I say not always the case, but I think it certainly helps, because when when you start to look at what your issues and your problems are and your risks, you need to understand a little bit about the items you're trying to look at, trying to assess the equipment it goes into. From my perspective, ideally some sort of engineering background, but I have also seen very successful obsolescence managers come from supply chain, ILS, and indeed just project management as well.
I suppose you've got to be analytical, haven't you, as well, and a good communicator, talking upstream, downstream, and within the organisation as well. I think you've got, like you say, many different soft skills there as well.
Yeah. But the communication plan is part of the obsolescence management plan, and that is so critical. You have a good communications plan that forms and drops into the obsolescence management plan. And this is where you need to be able to talk to various levels of an organization, from fairly senior management through to people actually doing day-to-day functions.
So I think the obsolescence manager's role is very much a jack of all trades, as in having a little bit of knowledge of everything, and you're relying on the knowledge of the functions, whether that be engineering, procurement, or otherwise, to tell you what the issues are and what the plan is to resolve that. And then you taking that information and piecing it all together to understand what the big picture looks like, and then you convene that or convey that back to the senior leadership team, so they can then endorse the decision going forward to resolve that particular obsolescence arising. I was just going to say there are a number of project management skills and soft skills that obsolescence managers utilize. The roles aren't dissimilar at all.
Okay. I want to move on to obsolescence risk management now. Now, Tim explained earlier that Diamond OM sort of covers a lot of that from a digital software perspective for management of it. But could we talk about basic risk management? Could we talk a little bit about likelihood versus impact, please, of parts, items, anything like that? How is that measured from a sort of a manual perspective, I suppose?
But likelihood is the first phase of the obsolescence management assessment process. And what we're talking about is likelihood of an item going obsolete sometime or becoming obsolescent sometime in the future. And it's based, in terms of IEC 62402 2019, on having a year's to end of production forecast, which you can obtain by any number of reasons, data mining, using third-party tools and so forth. The number of suppliers or manufacturers of that particular item, and the more manufacturers of that item there is, then your risk diminishes. And then thirdly is availability of the item to procure, and that forms up what they call the likelihood. To me, and availability in this terms is actually what we call procurability. It means you can buy from that particular source. In webs, we actually bring in a fourth one. We bring in availability. So we know we can buy that item from another source, legitimate source, that the client or the customer cannot buy from. And I take no-to stock numbering, for example, like that, where you have a list of manufacturers, equipment you can buy, and you can buy from them. That's what I call procurability. But there are other sources of supply that are legitimate on the marketplace that you can go and buy from. And this goes into a traffic light system of red, amber, green that gives you either a green, which is a low risk of likelihood of going obsolete. Medium is somewhere between, maybe you have 2 suppliers or something like that, rather than 1 or 4. And then green is where you've got all the way through that. You've got a good source of supply, you've got a good years to end of production forecast, and a good procurability of capability. The big problem with that, in that approach, is that many companies take a single source solution. So they buy just single source, and they've got a good contracts to do that. So what we've built into the Diamond tool is an ability to take that away from being a high risk into a medium or low risk. And the same applies for software, of course, because normally software, especially if you take Windows, you just have one developer. So that could classify as just one source of supply, which give you a high risk. I mean, in fact, that is not the true case. So that's likelihood of an obsolescence item. Likelihood of an item having an obsolescence impact on you sometime in the future. Impact is where we actually take the likelihood and assess it against our particular program. It's what we call the so what factor. So if you've got something that's going to have an impact on your obsolescence on your program, you can very simply, for example, and it's a very simple example, look at the stock you've got. And if the stock you have against the consumption rates that you've got predicted go beyond the life of what your program is, then that is then a resolution that's available. Then there are other impact assessments you can start looking at. You can start looking at criticality. You can start looking at repair. Can you repair the items? Can you start looking at rising rates to see what the issues are? There's a whole raft of actions that go into the impact assessment. And what we've built into Diamond, we've built in basically like a toggle switch capability where you can switch toggles on to say, I want to have inventory versus consumption rates. I want to have failure information, like from reliability modeling or from a FAMICA type reporting back from of failures, from turnaround times, from MROs. You can choose a whole raft of those capabilities to produce you a really quite finite impact assessment based on your company. Then once you've got all that information, of course, you're then into looking at saying, I've got a problem. The impact, I do have an impact of this likelihood. Then what is my resolution? What's my approach to the resolutions? The use of criticality, in terms of impact assessment, the use of criticality is sometimes used by companies to replace any other information they've got. If they haven't got any failure information, no stock, no inventory, they want to know what the criticality of those items are that they've got, so they can then prioritize the impact of view on criticality of item. Now, that is at the item level. Then when you actually do the overall picture of what your impact is on your system, you will then start to look at a series of criticalities of where that equipment's operational. And if I take a very simple one of a ship, for example, then mission critical is obviously fairly high. Then the sort of fight, move and float is high. But then just some other things can be fairly low in criticality. But that's all part of the assessment you look at of when you want to of assessing the obsolescence management activity. So there's two things: there's criticality of the component, and there's criticality of the equipment stroke platform that it goes into and its operational criticality.
And that criticality assessment will drive whether your obsolescence strategy will be proactive or reactive.
Yeah, it's normally quite often used also to provide priorities in investment in obsolescence management. So obviously, if it affects fight, move, and float for a warship, it's highly critical. If it just affects, being alongside and filling up, then it's less critical. That's perhaps not a very good example, but
okay. I want to talk about something that we've not covered going into the final sort of part of this podcast is obsolescence management planning in design. So before we've talked about a lot about in manufacturing assembly, we've not really talked about design. So what are the major elements of where it impacts in the design stage of a product, an item, a tank, a machine in industry?
So in my view, I'll talk at the moment. David, you can have your view after my view. So in my view, obsolescence should start right at the beginning, of the concept phase of the item or the product. And things that you can look at are things like preferred parts lists. So when you come to choose your components, you know that you've got longevity in those various technologies that will allow you to have that longevity and support.
Yeah, effectively, one of the things we have to be really cognizant of is that when we start to design a product, we probably at the design stage have committed to probably 60 to 80% of the material costs. So therefore, it's so important that at that stage, and one of the most fundamental ways of stopping short or medium-term obsolescence is to ensure that when we design something, we design with good strategies, looking at the technology, especially if it's electronics, looking at roadmaps of semiconductors, memory devices, to make sure there's a good roadmap going forward, bearing in mind obsolescence occurs across every type of item, but also is more prevalent in the long sustainment programs. So therefore, when we go into the design phase and even in the concept phase, we start to look at using well-known and well-respected roadmap products that we build into our design. Most companies these days, I'm pleased to say, tend to have what we could call a preferred parts list or a preferred items list or common components database, especially when we're talking electronics. And those companies that are designing something, especially with a long design period, should choose from those particular items lists. And I'm pleased to see that most companies do that now. This protects the short to medium term period of design into manufacture. I have worked on programs and experience of programs where it's been a fairly long design period, and by the time it's got into manufacture, it's been 50% obsolescence. So having a good preferred parts list, components management plan, and there are some standards around, especially for the aviation and electronics worlds, to conform to those sort of company policies and plans. And then if you want to move outside of that for some sort of other type of item, you get approval from your organization to add it to the parts list. So you're controlling very much the items that go into your initial design. Now, the next stage is to make sure that an obsolescence risk assessment is available at the first design review. So most companies have design reviews. So when you go through your design review with whatever criteria you have into your design reviews and contribution to the design review, you have an obsolescence risk assessment. And that risk assessment should look at at least the minimum length of your contract. So you're protecting as best you possibly can the use of items that will not go obsolete or minimal chance of going obsolete in the near term. Next, you have to be cognizant of what's going on in the legislation world and understand, is there going to be an impact from something like REACH, future dates of substances of very high concern going onto their register. So you need to also consider those sort of aspects. Then the next thing you have to do, if you've got software involved in your program, you have to make sure that there's a good roadmap for the software you're choosing. So you're choosing software that has a roadmap, again, that provides longevity to your program. And thirdly, if you're using field programmable gate arrays, make sure you always use gate arrays that can be multi-programmed. Some gate arrays can only be programmed once. So therefore, if you want to upgrade it, you've got to replace the gate array. So make sure you're using field programmable gate arrays that can be multi-use. So that is very much in the early design phase. Then making sure that your design tools, and this is it could be the schematics that capture your board designs, it could be your overall product engineering tools, they actually link to the obsolescence management world. So therefore, any component you choose on your design, it goes into your items list, which most companies control through a product lifecycle management system. They actually link to the obsolescence, and you choose items that are going into design that have got a good life. And this is where, again, having the integration of obsolescence management tools into the design world and into lifecycle management forms a complete picture at the design phase. IEC 62402 2019 does have a number of strategies that you should look at when you're designing. This is modularization, transparency, and so forth. There is a list in 2019 that they say is good design practices.
One of the sayings within defence world is design the support and support the design. So ensuring that when you are designing a product, that product is supportable. through its life and maybe beyond that. And so understanding everything that David's just alluded to there is paramount.
We did this quite late on in the podcast, but I believe from listening to you guys that this is probably the most important section of managing obsolescence properly at the design stage, because if you get it wrong here, then it causes problems downstream, doesn't it? Further on.
It does. So we have a whole range of case studies of our equipment going into production, going into service support, and of being obsolete, with items obsolete before they even actually go into service. I can quote you one without naming the program, but there's a program that's, I think it's now 5 to 6 years before it actually goes into delivery, has already got significant obsolescence in because of the longevity of the design period that it takes. So, yeah, it has a big impact on long-term programs. Shorter-term programs, perhaps not so. We have a big impact, of course, on supply. That most of the electronics are governed. If you look at the semiconductor world now, the aerospace and defense, if you come from that world, is less than 0.1% of the semiconductor market. All of the semiconductors go to commercial programs. So again, it's so important to choose the right family of components at the very beginning in terms of aerospace and defense. And the same applies to the oil and gas industry, subsea oil and gas. You know, we've done work with them. They have exactly the same problems as the defense industry, as does the automotive, the rail industry, cruise ships. They all have exactly the same problem. We've even worked on a program with a pharmaceutical company to identify obsolescence on their production lines. So it's not just aerospace and defense; it is a whole industry. And of course, one of the big tests we're going to get is when we start really doing high-scale electric car manufacture. That's going to have an impact on availability in other markets as well.
So one of the key issues with the later you leave, if you don't manage obsolescence through life, is the opportunities and the of resolution become diminished and can become quite costly, because you end up probably driving for either a minor or a major redesign. And we've seen that with, Challenger 2 tank that didn't have any upgrades for about 19 years or so. And so you end up with a capability that's not what it was designed for.
I think if Tim's right, if you look at the cost curve for obsolescence management, it starts very low, and over a period of time, it exponentially increases. And the role of the obsolescence manager is actually to keep that cost curve as far to the left of the curve as you possibly can.
Guys, this has been a really informative podcast. I've got one final question for you both. Get your crystal balls out. So what do you see obsolescence management being like 10, 20, 30 years from now? How do you see the future?
Obsolescence is one of those topics that will be with us forever. And I could see it becoming quite mainstream and a more integral part of support, or design and support. And I think it will get the recognition it needs in terms of the funding required and the organisation and the tools and the information it requires to do that job properly, to allow that capability and service to be made available whenever the client requires it.
David, do you concur with what Tim said there? Because the only thing I can see is technology is growing that quick now. I mean, AI this year is a massive factor in life in general. Not really heard of sort of 4 or 5 years ago, just under the ground. Now our technology is changing on such a rapid curve. Obsolescence management is going to get more difficult, surely.
Well, I think the solutions are going to get different, become different. We all know about 3D printing. and I can see that, especially in many areas, that 3D printing will become replace what we call reverse engineering and things like that on various, especially hardware programs and products. So I can see 3D printing, at least in the next 10 years, it is already prevalent in many organizations in terms of replacing the original items. And I can see that becoming more prevalent as the future goes, that we will use 3D printing in certain areas and to resolve obsolescence. I see more emulation. For example, if you take logical controller, program logical controllers, which is a piece of kit that's normally hardware, that's normally got some software written into it, we're seeing some of those replaced by emulators on PCs now. So I can see more emulation replacing these type of tasks. I see as you quite rightly say, I see AI being used to do a great deal more predictions. Normally, in the electronics part of the obsolescence management, if you don't have an answer for the life end of production forecast, they use algorithms. We use algorithms as well, based on a lot of them are based on what's called the EIA 6724. But I can see now, when we take obsolescence programs into the future, we take the items list in, we actually can start to assess the number of type of part items in there, whether it's got semiconductors, whether it's got capacitors, whether it's got pumps, valves, whatever it may be. And we can use AI to predict the life cycle of that equipment. This is way before we even get to breaking down the equipment into understanding the reality of obsolescence. So I do see AI being a promulgated into the use of future predictions of equipment. We can then plug into things much more like failure information into the AI to give us a much better life cycle approach. So holistically, I see quite a bit of change coming in the future in how we would address obsolescence management. But Tim is quite right. I think we're actually starting now to see the prime customers looking at actually funding obsolescence more than it has done in the past, understanding obsolescence. I also see that that they will want to move risk around. I think customers want to remove the risk from them to people like the primes who work for them or who do produce the equipment. So I see the risk going down into the manufacturing side. And I also see the growth of data is going to become more available. And data is an important part of doing the assessment. But long term, I think 20 years from now, I think the role will be considerably different to what it is now.
Fabulous. Well, I'll leave links to everybody who's enjoyed the podcast. I'll leave links at the bottom for Alan Webb, the website, consultancy, training courses, pretty much everything you've heard on this podcast, Alan Webb supports on, and they've been doing it for a long, long time. The brains within Alan Webb is incredible within obsolescence management and beyond sustainability engineering. Also, I'll leave links to the Diamond OM website, which is the software that you can manage obsolescence on yourself or with help from Alan Webb as the consultants. Please like and subscribe, follow for more content. We've got a lot of content like this about various subjects within industry and defence and all other sectors too. And thank you, Tim. It's been fantastic. Thank you, David. Thank you very much.
Thank you very much for listening to this podcast, and hopefully we will see you at either IOM meetings in the future or any events that we are actually demonstrating at.
Perfect. Thank you.